All right, so we're going to do some more stuff with implicit today. So this first one, you should be an expert on being able to find the derivative, finding dy dx. So let's see if you can do it. It says, given this equation, find the equation of the tangent line at the point 2, 1. So you need a point. Luckily, they gave it to you. And because these aren't functions, a lot of time with implicit they will. But now I have to find the derivative. So you do that using implicit. And you would have 3x squared plus 3y squared dy dx is equal to 4xy, so I have to do the product rule. So I'm going to do 4x is my first and y is my second. First times the derivative of the second plus the second times the derivative of the first would be a 4. And then plus 1, that would be 0. So dy dx, I will make those on the left. So I'll keep my 4y minus and move that 3x squared over. I'll factor a dy dx out, and I have 3y squared minus 4x. So dy dx is equal to 4y minus 3x squared all over 3y squared minus 4x. I'm not done. That's good that I have that, but I'm going to need more stuff. So I'm going to evaluate dy dx, and remember the notation for that. I'm going to evaluate dy dx at the point 2, 1. So I put that notation down there. So that would be 4 times 1 minus 3 times 4 over 3 times 1 minus 4 times 2. So what do I have? 4 minus 12, that is negative 8. And then 3 minus 8, that's negative 5. So those negatives cancel. So my slope is 8/5. I do look again and make sure that I'm doing the tangent line, which I am. So it's y minus y coordinate is equal to slope, x minus x coordinate, and there is the equation of my tangent line. So perfect. Perfect, perfect, perfect. And like I said yesterday, I technically could have not cleaned that up. I could have solved for dy dx right there and plugged in the 2 and the 1 at that point. So let me just show you that, because on this one, the solving wasn't that hard, like solving for dy dx. But I will tell you on AP, sometimes there are ones that are difficult. So notice I could go in this line. I'll do it in a different color so you can see what I'm doing. I could go in that line and plug in the 2 for x and the 1 for y. So I would have 3 times x squared, so that would be 3 times 4, which is 12, plus 3 dy dx, because I plugged in y being 1, is equal to 4 times 2, 8 dy dx, plus 4. And notice what happens is I bring the 4 over here, so that would be 8. I bring the 3 dy dx over there, that would be 5 dy dx, and so dy dx at 2, 1 would be equal to 8/5. So some people say it's kind of silly to do that and clean it up all pretty when I could just go ahead and plug it in there. So that is your choice, and you can decide what you like better. So find the equation of the tangent and normal lines at x equals 1. Okay, let's see if I have enough space to do all this in. So this one, I just said that they normally give you the coordinate. This one they didn't. So let's find the point. Notice if I plug in 1 for x, I would get y squared is equal to 4. So y could be what? Oh gosh, y could be plus or minus 2. So I've got 2 points that I have to find the equation of the tangent and normal line for. So I've got to make sure that I write my answer that my grader knows what I'm saying. Well, either way I go, I'm going to have to find the derivative. So let me find that derivative. 2y dy dx is equal to 4x, just 4. So dy dx is equal to 4 over 2y, and I'm going to simplify to make my life easy, and that would be 2y. So I can find the derivative very easily, but I'm going to set up my answer and in a kind of a chart form, I guess, because I need my grader to know exactly what I am doing. So let's evaluate. Let's do dy dx. Evaluated, what were my 2 points? One of them was 1, 2. And so that would be dy dx at 1, 2 would be 1. And dy dx evaluated at 1, negative 2 is going to be negative 1. Everybody see where I got that? So here's how I'm going to write my answer. I can go straight to the answer at this point. So I'm going to say at 1, 2. At this point, my tangent line is what? My tangent line, my point would be y minus 2 is equal to, my slope was 1, which it's kind of silly for me to write the 1, and then x minus 1. The normal line at that point would be y minus 2. The reciprocal of 1 is negative 1, so I'll just write negative 1, x minus 1. And those are the tangent and normal lines at that point. At 1, negative 2, my tangent line was, that would be y, don't know why I put the parentheses there, but I just did. Y plus 2 is equal to this slope, x minus 1. And then the normal line would be y plus 2. The reciprocal of negative 1, of course, is 1. And then the opposite reciprocal, so I'd do a positive 1. And then x minus 1. So your paper should be set up just like mine. Your grader has to know what the derivatives are at the points where you got those numbers, what the equations of the tangent normal line, everything's labeled and all beautiful, just like your paper should be. Now the second question said, at what points is the tangent line horizontal and what points is the tangent line vertical? Well, let me ask you. Remember, here is our derivative right here. So if I ask you, when would something have a horizontal tangent? Finish this statement. Horizontal tangent if dy dx what? And hopefully you said equals 0. So look at your dy dx. If you set 2 over y equals 0, do you get anything? No, because a fraction is never going to equal 0 if the numerator can't be 0. So our derivative can't ever be 0, so you would write no horizontal tangents. There isn't a horizontal tangent. Well, let's do a vertical tangent. Finish this statement. Vertical tangent if dy dx, what? Is undefined. I'm trying to squeeze this all in. I'm not sure if I'm going to make it. I'll get some white space over there. So let's look at our derivative. Again, 2 over y is undefined when what? Well, it's undefined when the derivative equals 0, or when the denominator, rather, equals 0. So this derivative is going to be undefined if y equals 0. Now notice it says at what points. So that means I have to get the points. So I have to go back way up to my original, which I'm not going to move my screen, but at the top of your paper when it says example 2, your original was y squared equals 4x. So I have to plug 0 in for y and get 4x, and I have to solve for the x coordinate. And I actually get also 0, which means I have a vertical tangent, I'm going to abbreviate, at the point 0, 0. So you have no horizontal tangents, but you have vertical tangents. So when you're getting those points, you have to remember to go back to the original question. Okay? Alrighty. Let's look at this next one. Now this next question is kind of weird. The question is, what is the second derivative of, this is still in the same part, so what is the second derivative? And they actually gave you multiple choice answers. So you're like, okay, I got to get down to one of those. So let's see where we're at. We know that, I'm going to give myself a lot of room. So let's rewrite. Remember, our dy dx was 2 over y. And being that I'm about to take the derivative, I could do the quotient rule, but it would be very easy to write that without the quotient. So it probably would be smart for me to do that. Now remember, the second derivative is the derivative of the derivative. So here's where this notation is. I'm taking the derivative of dy dx with respect to x. And that's why the notation for the second derivative is d squared y over dx squared. That's what I'm looking for. So what I have to do on the right is take the derivative with respect to x, so I'm just making sure that you understand what I'm doing, of this thing right here. In other words, I have to do implicit on this. So you will do implicit on that. Implicity? I don't know where I got that extra y, but just felt like writing it, I suppose. So I'm going to do implicit on 2y to the negative 1. So the derivative of that with respect to y would be negative 2y to the negative 2. But I'm taking the derivative with respect to x, so I'll get dy dx. You will always get a dy dx when you're taking the derivative. Okay? You've got to plug in what this is. Remember that dy dx back up here was 2y to the negative 1. So what does that give you? That gives you that the second derivative would be negative 4 y to the negative 3, which I don't see any negative exponents, so I'm going to just do it like that. Negative 4 over y cubed. Now look at your answer choices. Oh, A looks so close. B, C. Well, dang, I don't see my answer anywhere. So does that mean I mess up? Nope, I didn't mess up. They just want to make you work a little bit more. Here is my hint to you. They don't always do this, but if it is multiple choice and you don't see your you don't see your answer, ask yourself, have I used original equation? And if you've said no and you don't see your answer, listen, if they have negative 4 over y cubed, you're done. But my point is, Have you used the original? When I say the original, I mean, again, that very first statement, the very first y equals, or y squared rather, equals 4x. Have I used that to simplify my second derivative? Well, I haven't. And you go, well, how do I use it? Well, if I have negative 4 over this y cubed, I could write, couldn't I write that as y squared times y? And if y squared is equal to 4x, I could write that as negative 4. I could use the original and plug in what y squared was, and oh my stars, what do I get? These cancel, and I get negative 1 over xy, and that is an answer choice, and so that's what I would pick. So you have to find the answer choice that is there. And where they stop, it just depends. It depends who was writing the test. It depends how nice they were feeling. So yes, they could have stopped there, but if you don't see your answer choice and you haven't used the original, look to use the original to simplify. But the key for the second derivative is right here where you remember to plug in for dy dx, and you'll always have to do that. Okay, so do some work on this, and then we will shift to related rates tomorrow. All right, peace out.